This is SpaceTime, Series 26, Episode 132, for broadcast on the 3rd of November 2023. Coming up on SpaceTime, the rare heavy element discovered in a stellar collision. All systems go for our next planetary defense mission. And Moscow threatening Star Wars in orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected the rare heavy element tellurium being produced in a kilonova collision between a pair of neutron stars. The findings, reported in the journal Nature, were made by teams using an array of NASA's spaceborne telescopes, including the Webb Infrared Observatory, the Fermi Gamma Ray Space Telescope, and the Swift Observatory. Astronomers observed an exceptionally bright gamma-ray burst, catalogued as GAB 230307A, was caused by the merger of a pair of superdense neutron stars. During this massive explosion, known as a kilonova, Webb also helped scientists detect the chemical element tellurium in the explosion's aftermath. Whereas a supernova occurs when a large star explodes at the end of its life, a kilonova is an explosion produced by a neutron star merging with either another neutron star or with a black hole. Other elements near tellurium on the periodic table, things like iodine, which is needed for life on Earth, are also likely to be present in the kilonova's ejected material. The study's lead author, Andrew Levin from Radboud University, says that just over 150 years since Dmitry Mendeleev first wrote down the periodic table of elements, scientists are now finally able to fill out most of the remaining blank spaces, understanding the origins of where these elements came from. While neutron star mergers have often been theorized as being the ideal pressure cookers to create some of these rarer elements substantially heavier than iron, astronomers had previously been encountering a few obstacles in obtaining any solid evidence. See, for a start, kilonovae are extremely rare, making it difficult to observe these events. Short gamma-ray bursts, traditionally thought to be those lasting less than about 2 seconds, can be byproducts of these infrequent merger episodes. That places them in contrast to long-period gamma-ray bursts, which can last for several minutes and are usually associated with the explosive deaths of massive stars. And the case of GAB 230307A is especially remarkable. First detected by Fermi back in March, it was the second brightest gamma-ray burst observed in the last 50 years, about 1,000 times brighter than a typical gamma-ray burst. And it also lasted a long time, some 200 seconds, and that should firmly place it in the category of long-duration gamma-ray bursts, despite its different origin. The collaboration of many telescopes, both on the ground and in orbit, allowed astronomers to piece together a wealth of information about this event pretty well as soon as the burst was detected. After that first detection, an intense series of observations from the ground and in space swung into action, pinpointing the source on the sky and tracking how the brightness changed. These observations in the gamma-ray, X-ray, optical, infrared and radio showed that the optical infrared counterpart was faint, evolved quickly and became very red, all the hallmarks of a kilonova. This type of explosion is very rapid, with the material expanding quickly. As the whole cloud expands, the material cools off quickly and the peak of its light becomes visible in the infrared range, but then becomes redder on timescales of days and weeks. An important contribution to the observations were made by NASA's Webb Space Telescope. Its near-infrared camera and near-infrared spectrograph were used to study this tumultuous event from space. Webb's spectrograph produced a spectrum of broad lines that showed material being ejected at high speeds, and one feature stood out really clearly: the spectral lines emitted by tellurium, an element rarer than platinum here on Earth. The highly sensitive infrared capabilities of Webb also allowed astronomers to identify the location of the two neutron stars that created the kilonova, a spiral galaxy about 120,000 light-years away from the site of the merger. It seems that prior to their cataclysmic adventure, these were two normal massive stars that formed a binary system in their home spiral galaxy. Now, since this duo were gravitationally bound, both stars were launched together on two separate occasions. Firstly, when one among the pair exploded as a supernova, then became a neutron star, and then when the other star followed doing the same thing. The two supernova explosions flung the pair further and further away from their host galaxy. But the two stars remain in a binary system, even though they travelled approximately the equivalent of the Milky Way's diameter before finally merging into a single object 100 million years later. This is space-time. Still to come, an update on the European Space Agency's Hera planetary defence mission, and Moscow getting more and more aggressive with the Kremlin threatening Star Wars in orbit. All that and more still to come on Space-Time. The European Space Agency's Hera spacecraft has now arrived at ESA's STC test centre in the Netherlands as it continues preparations for next October's launch on its planetary defence mission to the asteroid Didymos and its small moon Dimorphos. The mission will undertake a detailed investigation of the changes that NASA's DART impactor mission did when it collided with the 160-metre wide moonlet just over a year ago. Launched back on the 24th of November 2021, the DART spacecraft successfully slammed into Dimorphos on the 26th of September 2022, about 11 million kilometres from Earth. The collision left a massive crater in Dimorphos, and there was a 10,000-kilometre-long debris stream trailing behind the Moon. It also pushed Dimorphos closer to Didymos, shortening its orbit around its host by some 32 minutes. The Hera spacecraft, together with its two nanosatellite CubeSats, Alani and Juventus, will fully characterise the composition and physical properties of the binary asteroid system, including their subsurface and internal structures. The information obtained will help inform scientists on the success of the kinetic impactor method for deflecting a near-Earth object that's threatening to crash into the planet. This report from ESA TV.
Somewhere in the vastness of space might well lurk an unobserved asteroid, on course for a head-on collision with our planet. Its impact could be devastating for humankind. Should we not wish to experience the fate of dinosaurs, we best be prepared. This is also the view of ESA and NASA, as both agencies invest in locating these lonesome wanderers and seek to prepare a planetary defense strategy. As ESA's Hera spacecraft arrives at the STC test center in Noordwijk, the Netherlands, humankind takes another step towards a safer future for our planet and its species. The test center at STC is the largest and best satellite testing facility in Europe and is equipped to simulate all aspects of spaceflight, from the force and noise of a rocket takeoff to the sustained vacuum and temperature extremes of deep space. This allows new spacecraft, such as Hera, to efficiently undergo the crucial tests needed to qualify for launch.
We need to make sure that the satellite works, which means the software, all the different pieces of software together work, and it does what it's supposed to be when it's going to be alone into space. And this entails not only doing the nominal operations, but even more importantly, to be able to react in case of failures, in case things go wrong, or things go differently from what we have planned.
At the facility, Hera will not only receive her metaphorical wings, proving her worthy of flight, but also its solar wings will be installed here. Finally, the spacecraft will be ready to meet its tight October 2024 launch window in order to make its appointment with the binary asteroid system Didymos and Dimorphos. The Hera spacecraft is part of a larger program. Only a year ago, NASA's DART mission successfully impacted on Dimorphos, shifting the celestial body's orbit as planned. Now, Hera will survey the aftermath and the asteroid up close to help turn this grand experiment into a well-understood and potentially repeatable planetary defense technique.
One of the interesting aspects of Hera is that for the first time we bring 2 CubeSats with us. These are very small spacecraft, similarly to drones, that will go very close to the surface of the asteroid and gather complementary information to Hera. They will have ground-penetrating radars, they will have multispectral imagers. All of this, and as going closer, of course, they will take more risks. So the idea there is that we fly cheaper systems closer to the danger zone and keep Hera at a safe distance.
So, it is not only Hera that needs to be tested, but also the CubeSats it carries with it, and how the trio of spacecraft will work together in deep space.
Out of all these tests, which are typically performed on all the spacecraft that are launched into space, one of particular interest will be the one in the anechoic chamber, when we will assess the what's so-called electromagnetic compatibility. In that framework, we will operate for the first time the CubeSat and the mother spacecraft communicating to each other via this inter-satellite link. This is one of the primes of the Hera mission in deep space.
Hera is a unique spacecraft, and compared to similar missions like Rosetta, Hera is about 10 times smaller and cheaper. An enormous achievement for the team. Soon, Hera will leave ESTC and be fully ready to take on the vastness of space and explore Dimorphos, teaching humankind about strategies how to defend itself against the asteroid that could end it all.
And in that report from ESA TV, we heard from Hera project manager Ian Carnelli and Hera lead systems engineer Paolo Martino. This is SpaceTime. Still to come, the Kremlin threatening Star Wars in orbit. And later in the science report, could Tai Chi help slow the progression of Parkinson's disease? All that and more still to come on SpaceTime. As Moscow continues its war against Ukraine, the Kremlin's also continuing to ratchet up its threats against the West. Russia's already threatened to use nuclear weapons on several occasions in response to ongoing economic sanctions by the West over its Ukraine invasion. And now they've begun saber-rattling in space by undertaking what are known as rendezvous and proximity operations by moving one of their Luch Inspector satellites aggressively close to a Western spacecraft in geostationary orbit. The maneuver was reported by the private company Slingshot Aerospace, which uses algorithms and artificial intelligence to track satellites. The company says the intercept was undertaken by Moscow's Luch 2 spacecraft, which was launched in March this year. Its predecessor, Luch 1, which was launched back in 2014, also undertook several close flybys of other nations' spacecraft, often travelling to within 10 kilometres of the satellites, and for reasons which Moscow refused to explain. Now Luch 2 is following in its predecessor's footsteps, undertaking a similar manoeuvre, moving within 60 kilometres of a Western satellite. But none of this is new for the Russians. Back in January 2020, we reported on the Russian Cosmos 2542 and Cosmos 2543 satellites, which manoeuvred close to an American Keyhole KH-11 spy satellite. And 6 months later, in July, the Cosmos 2543 spacecraft fired a projectile into space, demonstrating a new capability. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. New researchers found that Tai Chi, the ancient Chinese martial art that involves sequences of very slow controlled movements, could slow the progression of Parkinson's disease. Parkinson's disease is a progressive neurodegenerative disorder that causes tremors and restricts movement. To investigate the potential benefits of Tai Chi for patients, researchers followed the disease's progression over 5 years in 147 patients who took Tai Chi classes twice a week and 187 patients who didn't. The researchers say that at every monitoring point, disease progression was slower among Tai Chi patients compared to those who did not participate in the classes and were more likely to need increases in their medication to manage their symptoms. The findings, reported in the Journal of Neurology, Neurosurgery and Psychiatry, cannot prove that Tai Chi classes slowed the disease's progression. However, it does show that the practice should at least be considered for people with Parkinson's. A new study has found that lead exposure is likely to blame for 5.5 million adult deaths from heart disease each year, and also for a loss of 765 million IQ points in kids under 5 globally every year. The findings, reported in the Lancet Medical Journal, suggest that up to 95% of those effects were found in low and middle income countries, with the affected children losing an average of 5.9 IQ points before they reach the age of 5. Researchers say these health effects are similar to the dangers of both outdoor and indoor air pollution combined, and 3 times worse than the effects of drinking unsafe water, having poor sanitation, and incorrect hand washing. Additionally, they estimate that the global cost of lead exposure annually could be over $9.3 trillion, equivalent to 7% of global GDP. A bit of good news now, and a new study claims that getting just 20 to 25 minutes of exercise every day may be enough to offset the heightened risk of death from highly sedentary lifestyles in people over the age of 50. A report in the British Journal of Sports Medicine analysed 2 years of activity tracker data from almost 12,000 people aged 50 or over. They found that being sedentary for more than 12 hours a day was associated with a 38% heightened risk of death, but only for those undertaking less than 22 minutes of daily moderate to vigorous physical activity. Have you ever noticed that when people talk about ghosts and ghouls and hauntings and things like that, it usually involves spirits from a long time ago, usually from something ancient, medieval, or at least from Tudor, Elizabethan or Victorian times? Tim Mendham from Australian Skeptics points out you seldom hear about the ghost of some Fonzie-like greaser who croaked in the 1950s.
Why are there no new ghosts is the problem. Because people talk about ghosts and buildings being haunted, and you can hardly find a pub in England which doesn't have its own ghost. Also, you can't actually hard to find a museum in America which doesn't have a ghost, which is interesting. The trouble is they don't have new ghosts.
Yeah, they're all from the Middle Ages or 300 years ago or something like that.
Yeah, or Victorian times. As someone pointed out, they don't know of any ghost beyond World War II. Where is the bikie ghost? Where is the person in a bad suit from the 80s ghost?
Safari.
Where are all these people ghosts? There are always people in Victorian clothes or diaphanous gear and something and looking a bit strange, and the person's been wandering the halls of this castle for 5,000 years. Where are the new ghosts? And it's a question that people are asking for. People are still dying. Shouldn't there be modern ghosts? And I'm trying to think of some.
Oh, I'm
also trying to think of why there are not many animal ghosts.
So have you reached a resolution on this?
One of the suggestions is that who's going to be scarier? If you're going to have a ghost, you might as well have something who was a person who was stoned to death as a witch in the 1600s, or someone from the 1970s who was just stoned and fell out a window. Obviously, the old person is going to be the older, that a witch or ghost is going to be a more effective tool for scaring people.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.